Okay, let's look at multiplying and dividing. First of all, back in grade, whatever, we learned to multiply fractions. Simplify multiplying the tops. 1 times 1 is 1. 2 times 3 is 6. Circular answer. Check it on the calculator. Okay, 3 over 8 times 4 over 9 equals. Now remember, we could do this multiplication, but we'd rather cross cancel. So we can divide the top and bottom by 3 and cross off the 3 and the 9 and say 1 and 3. We can divide the top and bottom by 4, so cross off the 4 and the 8 and say 1 and 2. Then we can multiply. Equals 1 times 1 is 1. 2 times 3 is 6 equals 6. Cross canceling. That's in a box off to the right. There's an interesting version of cross canceling. Well, the theory behind it, and then how to do it like I just did. Okay, let's remember fractions. So let's take a over 2 divided by 1 over 3. Remember, we take a over 2 and we flip the second fraction and change to multiply. Okay, the next one, we have 1 over x plus 2 times x plus 2. Well, what's this equal to? Well, we literally have an x plus 2 on the top and the bottom. Cross them out, divide the top and bottom by x plus 2, and it's equal 1. State your restrictions. X plus 2, setting any denominator ever, can't equal 0. X can't equal negative 2. Cross-reference, your answer, or, excuse me, not until equations. So x can't equal negative 2. We're not solving, we're just simplifying expressions to be things, circling our answer, and circling our restrictions. So, the example off to the right I'm going to put below is 1 over x plus 2, x plus 3 times x plus 3. Now, when I'm timesing these things, I want to think. Don't actually do it. What cancels? What are we left with? Don't forget to state your restrictions. So again, think what cancels, what are you left with? So what if I have x plus 2 over x plus 3 times 2 over x plus 2? Well, I'm going to put brackets around everything and realize I don't have any plus or minus signs in between the brackets, so I can divide the top and bottom by x plus 2. I can cross off the x plus 2 from the bottom to bottom. I can say 2 over what I'm left with. Circle your answer. State your restrictions. So instead of actually multiplying, think what you can cancel. Then write what's left. We're going to use that a bunch. Okay, shrink that up a bit. So we're still multiplying and dividing, so let's take x plus 1 over x squared minus 5x plus 6 times x minus 2 over x squared plus 5x plus 4. Now, I'm going to factor these things right where they are. Two numbers that multiply to get 6 and add to get negative 5 are x minus 3 and x minus 2. I'm going to factor this one. Two numbers that multiply to get 4 and add to get 5 are x plus 4 and x plus 1. Now, you can clearly see I have an x plus 1 on the top and the bottom. And I have an x minus 2 on the top and the bottom. And I'm left with a 1 on the top because there's nothing there. And we were dividing. And we're just left with that. So, if that process where I factored things directly in the question, directly near it, is difficult for you, don't do that. Bring it off to the right. Do it and then bring it back in. So, the next two examples are division. Remembering, for division, we just flip the second fraction, change to multiply, and then it's exactly like the examples above. Remember, your restrictions for division is any denominator ever. Can't equal 0. So it's before the flip and after the flip. So usually it's a good idea to state your restrictions first. So that's multiplying and dividing. Keep in mind, you might get complex fractions where you have to add and subtract and then multiply and divide. But let's take a look into now adding and subtracting rationals.